let's take a look at just a few more problems that we are going to use dimensional analysis or the factor label method to help us solve. First one says that our hose fills a 2-gallon watering can in 20 seconds and that 1 cubic foot holds about 7 gallons of water, and our job is to figure out how long it will take to fill a 3 by 8 by 1 foot kiddie pool. Okay, a lot going on there. So first off, what do we know? We know a couple ratios, 2 gallons to 20 seconds. I'm not sure if I'll use it, 2 gallons over 20 seconds or the reverse, but at least I've got the ratio. The other thing we were told is that 1 cubic foot is about 7.5 gallons. So a cubic foot, 7.5 gallons. I've got two ratios that are going to help me solve this. What else do we know? Well, we're told something about the size of the pool. Volume is length times width times height. We're given all three of those dimensions, so we can calculate that this pool holds 3 times 8 times 1, or 24 cubic feet. Now we're ready to solve the problem. So we're going to start with our 24 cubic feet. I always put it over 1, and I want that cubic feet to go away, so I'm going to use my ratio up here of 1 cubic foot to 7.5 gallons. So the cubic feet are going to cancel. And now I'm left with, so if I mark that, cubic feet are going to cancel, right? Now I've got gallons, but I want those to go away because in the end I'm looking for time. So we're going to use our second ratio up there, and we are in fact going to put it in as seconds over gallons. So again, that the labels that I don't want cancel, and our final answer will then be in seconds. So in this case, if you get your calculator out and multiply across the top and the bottom, you're going to get 90 seconds or a minute and a half to fill this little pool. Let's take a look at one more. This is similar. This also is from your book. It says, a website says you will need 48 50-pound bags of sand to fill a sandbox that measures 8 by 8 by 1. How many bags would you need for a sandbox that is 6 by 4 by 1? Okay, here's a problem where they kind of give me some information that I'm really not going to use. I don't care how big the bags are. I don't care if they're 50 pounds, 100 pounds, 200 pounds, because the question is how many bags that I'm going to need. Okay, so not how many pounds. So that part of it is a little bit irrelevant. But what we do know is that 48 bags are needed for that 8 by 8 by 1 foot area or sandbox. Well, that's 64 cubic feet. All right, so this is the important ratio that we need. 48 bags for 64 cubic feet. Now, what about this new sandbox that's 6 by 4 by 1? Well, we're going to calculate that, 6 times 4 times 1, and get 24 cubic feet. So now we can solve the problem. Start with our 24 cubic feet. We'll multiply by 48 bags over 64 cubic feet. Why are we doing it that way? So that my labels cancel, and what I'm left with for my final answer is going to be bags, which in this case is 18. All right, one more. So last problem, soda is sold in 20-ounce bottles, right? Nutrition label for one of these is shown, and we know that a packet of sugar, like you have in a restaurant on the table, is about 4 grams of sugar. So if you're drinking a 20-ounce soda, it's equivalent to eating how many of those packets? All right, now I know you see the answer there, but I just thought this was kind of a really interesting problem. So your 20-ounce soda, and looking at the label here, let's see, it says 30 grams of sugar for 8 ounces. So the grams over the ounces. So I'm making sure here I want my label to cancel. Now I'm into grams. What else do they tell me? They tell me 4 grams of sugar in a packet. Let's see, a packet, 4 grams of sugar, right? So now my 1 packet to 4 grams, the grams cancel. So what's my answer going to be in? Packets. When you do the calculations, it's 18.75. That should make us all pause a little bit to think it's like almost 19 little sugar packets that we're drinking every time we drink a bottle of Coke or Pepsi. I think I'm going to stop drinking so much of that stuff. Let me know if you have any questions.